This is where we left off last time. We're doing polynomial and rational inequalities. We've talked about inequalities before. For example, 3x plus 5 is less than equal to 7 minus 9x. And we were asked to solve those and put it into the other two notations. So what was our strategy here? Because these are linear equations, you have to get x by itself. You have to solve for x. Treat the inequality like an equal sign. So which x do we move? No. Yes, you saw that negative. Because -9 is smaller than -3. We have to add 9 to both sides. So move the smaller x to the larger x. 3 plus 9 is 12. X plus 5 less than equal to 7. Then we have to move the non-x's to the other side. Seven minus 5 is 2. Then we divide by 12 both sides. We get x is less than equal to 1/6. Graphically, since it's an equal to symbol, it's a solid dot, and x is less than that. So it goes to -infinity. That's graphing. And then we put it in interval notation. Oop, it's bracket because it's a solid line. All right, that's what we did in chapter 2, or end of chapter 1, beginning of chapter 2. We get to do the same with quadratic equations or higher order polynomials. Except now the graph won't be linear. It's going to be a curve of some sort. So let's look at the first example. We have x squared minus 4x minus 5 is greater than 0. Here are our steps. First, get rid of any parentheses. Check, there's none there. If the degree is greater than 1, then move everything to one side. Check, we did that. Factor to find the x-intercepts. If you can't factor it, what are you going to do? Yeah, quadratic equation. Because we need to find solid answers. They have to be x-intercepts that we're looking for. And I'll show you why in a second. So in this example, we can factor it out. Since the second sign's a minus, that means the signs are opposite. And the bigger number gets the first sign. So 1 times 5. Now we got to figure out what times what equals 5. Since minus, since second sign's minus, then if we subtract them, we get 4. Now, 5 times 1, 5 minus 1. Remember, since the first sign is negative, the bigger number goes to the negative. Just let's look what this means. One, two, three, 4, 6, -1, -2, -4, -5, -6. And the up and down doesn't really matter. The vertical movement doesn't really matter. So what are our x-intercepts? Right, we set both of those. We get -1 and we get +5. What's the shape of the graph? Is it going up or going down? Yeah, because the leading coefficient's positive and it's a degree 2, both ends point the same direction. Does it cross or bounce at the x-intercepts? Why? 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 No, you were right the first time. Because once you factor it out, look at the multiplicities. If the multiplicities are odd, then it crosses. If they're even, then they bounce. Remember that rule? If the multiplicities, once we factor them, if the multiplicities are even, they bounce at that point. If it's odd, they cross. And the y-intercept is at -5, so we put -5 there. So remember, our equation that we're looking at, once we get it to one side, is this one. Once you factor and draw the graph, determine the solution. What does that mean? The equation says this equation is greater than 0. So do we want our answers to be positive or negative? Yeah, because we want all the parts of this equation that are greater than 0. Where are they greater than 0? In other words, what this means is above the x-axis. So our solution is what? Where is the graph above the x-axis? No. It's everywhere from -infinity to -1. And from 5 to +infinity. That's where the graph is above the x-axis. We have to look at the domain of where the graph, because the graph goes on infinitely. Since it's quadratic, it goes forever both ways. The infinities are always parentheses. Why are they parentheses at the -1 and 5? No, because the inequality doesn't say so. I cannot equal 0. In other words, at -1, it's 0. I can't do that. It has to be above the x-axis. So that's why I use parentheses. If the inequality had a line underneath it, then I would have brackets there. Let's look at example 2. And I apologize for all those in TV land. I should have sent these sheets to you a long time ago. I'm sorry. I sent them to your remind, and you can follow along. Example 2. X squared plus 3x minus 5 is less than equal to x plus 3. What kind of equation is this one? Quadratic, because the largest exponent is 2. So what does that mean we have to do with both sides? Has to be one side. If the degree of the equation is bigger than 1, then everything has to go to one side. So we have to subtract x, and we have to subtract 3. So we get x squared. 3 minus 1 is positive 2x. -5, -3, they're both negative, so we add them. These disappear, so it's 0. So we got everything to one side. Now what do we do? Factor. Because we have to find the x-intercepts of this graph. The second sign's a minus, so they're opposite signs. And the bigger number is positive. Because we take the first coefficient, so 1 times 8 is 8. What times what equals 8? When we subtract them, we get 2. Yeah, 4 times 2, 4 minus 2. Solve both of those, we get x equals -4 and 2. Now, do we use open circles or closed circles? Closed, because it's equal, which means we're going to include those endpoints as our answers. Does the graph open up or down? Opens up. So from the intercepts, the graph goes up. And since they're since they're odd exponents, multiplicities, we know it's going to go through. And the y-intercept is at -8. So what part of the graph do we want? Let's look at. This is the part we're going to look at. Once we solve for 0, what part of the graph do we want? Here's the graph. We want it to be below the x-axis. Because it's less than, we want everything that's below or equal to the x-axis. So our solution is what? Nope. We're only looking for the domain, not the range. Look where the graph is below the x-axis. All this stuff is below the x-axis. It happens from -4 to 2. That's why we have the x-intercepts. Are they brackets or parentheses? Brackets. That's our answer. Because it's less than equal to. In other words, we can take where it's equal to, which means if it's equal to, it's on the x-axis. If it's not equal to, then we can't use those points. It's everything below there. Example 3.
Increasing and decreasing on one side, shading one side for the less value. Which part would you shade?
Because we want everything below 0. Well, yeah. Because this part here doesn't exist in the graph. Because the area of the graph is what's contained in the graph. So this is the area of it. Okay, everything's over to one side. We have a 0 on one side, which is great because we have our degree is greater than 1. How do we factor this? Take out 1x from both of those, so we have x squared minus 1. If this is confusing, what you remember, when you factor something out, to see what goes in the parentheses, divide your original equation by it. Because I took something out, x to the third minus x, I lose 1x. X over x is 1. Because you have to be able to go from here back up to the original equation. So we have to make sure we have that 1 there. Are we done? No. We can do something with this. What does that factor into? Yeah. No. I almost put 2 there. Yes, because this is the difference of 2 squares. So my x-intercepts are at, I have to have 3 answers. 0, -1, and +1, right? And all of their multiplicities are 1, so they're going to cross that graph. We have -1, 0, and 1. Are they open or closed circles? Open because it's a strict inequality. Okay, it's a degree 3, so what does that tell us the graph's going to look like? What happens to both ends? They go the same direction or opposite directions? Opposite directions. And since it's positive, this side goes up, this side goes down. If it was negative, it'd be flipped. Since they cross, we know the graph will look something like this. What part of the graph are we looking for? Everything above the x-axis. So the graph above the x-axis is right here and right here. So what's my solution? Remember, we're only looking for the x-axis, the domain. -1 to 0, and they're both parentheses because I can't use them. No. No. Where is the graph above the x-axis? So where is it above the x-axis? We know this is above the x-axis. That's between 0, -1, and 0. This is below, so we can't use that. Is this above the x-axis? Here's the x-axis. Is that above it? Yeah, it's above it. It goes from where? It goes from 1 to infinity. Yeah, don't overthink it. It's just what it is. This one is super simple just looking at it. It's where is the graph above the x-axis? It's above here. It's from -1 to 0. It's from 1 to infinity. Example 4. 3x to the 4th plus 10x is less than equal to 11x cubed plus 4. So what's the first step? So which one do we move where? Yeah, because here's the biggest exponent. It's positive, so everything, this has got to stay here. Everything will go on that side. If it was negative, we move it to the other side. So we got to get rid of the negative. They get the 11x cubed by subtracting it from both sides. And then get rid of the 4 by subtracting it from both sides. Three x to the 4th minus 11x cubed plus 10x minus 4 less than equal to 0. Okay. It's a fourth order equation. What do we do? How do we solve it? Can't do that with this one. Because if you put parentheses around there, nothing except the x squared and nothing except 2 factors out here, we won't get the same answer inside there. We'll get 3 minus 11. We'll get 5 minus 2. They're not the same. So we can't do that. Do we know anything else on how to solve this one? We can't use quadratic formula because it's not a quadratic equation. It's got too many terms. What did we do in chapter 4 earlier? The rational zero theorem. Whenever you're trying to solve a higher order polynomial, where Q is the first term and P is the last term. So it's 4/3. What do we do next? What are the factors of 4? What are the factors of 3? So 4 is made up of 1 times 4 or 2 times 2. So that means our possible answers are made up of 1/1, 2/1, 4/1. That's all of these over that one. 1/3, 2/3, and 4/3. So our possible rational zeros are these numbers. We have 12 possibilities. How many positives, how many negative answers are we going to get? Let's see, number of positives. We do these, it's the Descartes rule of signs. How many sign changes? Here's 1, here's 2, here's 3. There's 3 sign changes. So from positive to negative, from negative to positive, positive to negative. So we have 3 or 1. Because what if we have an imaginary or a radical answer? Because they have to come in conjugate pairs. So yeah, because those automatically are positive and negative, so you can't count those. How many negatives? What do we do to count the negatives? Yeah, so pretty much shortcut for this, if it has an odd exponent, just change the sign in front of it. So for the negative, it would be, that's a positive one, so it's 3x to the 4th. That's odd number, so it's going to change it to positive 11x cubed. That's odd, so it's minus 10x minus 4. So just only change if it has an odd exponent. Change the sign in front of it. Positive to positive, positive to negative, that's 1. So what this tells us, the number of positives, negative, and non-reals, we have to have a total of 4 since it's a 4th order equation. We can have 3 positives. We have to have 1 negative. That equals 4. So it's, or we can have 1 positive. We have to have 1 negative. That means we have to have 2 non-reals. Those are the only possible combination of answers that we'll have. How do we find them? Yep, we got to start from positive and -1 and do synthetic division. So we'll start with +1. Remember, we have x to the 4th, x to the 3rd, x squared, x, and a constant. We have to put numbers in each of those columns. So we have +3, -11, 0, 10, and -4. Then we use synthetic division. How do we do that? Drop the first one down. And then what do you do here? Just add straight up and down. -11 plus 3 is -8. So 1 times -8 is -8. 0 plus -8 is -8. 1 times -8 is -8. 10 minus 8 is 2. 1 times 2. So that one doesn't work. Let's try -1.
Oh,
Yes.
so non-real, yeah, the non-real.
Because what if we had one of our answers was a square root? If it's a square root, it has to have a conjugate square root because there are no square roots in here. The square roots have to cancel, so we have to have a conjugate pair. No, this is a legit question. 0, 10, -4. Bring the first term down. -1 times 3 is -3. -3 plus -11 is -14. Negative is positive, so we have a 14. Makes it 24. So it's neither is -1. So we keep on going. Our next, so it's not the 1, -1, so let's try 2, -2. 3, -11, 0, and -4. Two times 3 is 6. It's going to be negative. 11 minus 6 is 5. 2 times -5 is -10. -5, I'm sorry. So that's 0 plus -5 is -5. 2 times -5 is -10. The answer is 0. So, nope, not +2. Now, hold it. 2 times -5 is -10. I'm sorry, hold it. It's -10. So this makes it -10. That makes it -20. So it's still not good. 3, -11, 0, 10, -4. -2 times 3 is -6, makes it -17, makes it 34, -68. Let's try 4. 3, -11, 0, 10, -4. 4 times 3 is 12, minus 11 is 1. 4 times 1 is 4. 4 times 4 is 16. 4 times 26 is 104. So it's not 4. That's why I need you guys to do it yourself to see if I made a mistake. See if you get the same answer. Don't just copy mine, because I could be making mistakes. No, that one's not going to happen. So it's not any of the integers. So it's got to be fractions. So we have our fractions 1/3, 2/3, 4/3. And our equation is 3, -11, 0. So let's try positive 1/3. 1/3 times 3 is 1. Minus 11 is -10. Is -10/3. Makes it -10/9, which makes that 90 over 9, which makes it 80/9. Not going to happen. So we try -1/3. -1/3 times 3 is -1. That's -12. Negative is positive. 12 divided by 3 is 4. -4/3. That's where I lost it. So it's 30 over 3. So it's 26/3. -26/9. Nope, not going to work. That one doesn't work. 2/3. 2/3 times 3 is 2. 11 minus 2 is 9. 2/3 times 9 is 6. There's 2/3 times 9. The 3 cancels with the 9. 2/3 times 6. The 6 cancels with 3. 2 times 2 is 4. 10 plus 4 is 14. Oh, that's 6. That's just 6. It's 16. What's that?
So two-thirds times six, right?
2/3 times 6, because 3 goes into 6 twice. Times 2 is 4. No, it's positive. We add straight up and down. So it's 14. And that's not going to work because 3 doesn't go in 14. So let's try negative 2/3. We'll try this again. So that gives us 3. 2/3 times 3 is 2. Makes it, negative 9. Oh, that's where I messed up. It's negative 9. So that makes it negative 3 times 2 is negative 6. This one may work. Hold it. So then we have negative 6 times 2/3. So it's negative 4. 10 minus 4 is 6. 2/3 times 6 is 4. So the first answer is x equals 2/3. So this is our new equation we'll be using since we got a 0 remainder. So we try 2/3 again. 2/3, 3, negative 9, negative 6, 6. Two-thirds times 3 is 2. So it's negative 7. That's not going to work. Negative 14 over 3. No, that's not going to work. So we only have one of these. So now we got to try 4/3. Three, negative 9, negative 6, and 6. Four-thirds times 3 is 4. This makes it negative 5. Makes it negative 20 over 3. That makes it negative 18 over 3. Makes it negative 38 over 3. Not going to work. So negative 4/3. Negative 4/3 times 3 is negative 4. Okay, I might have made a mistake somewhere along the way here. So we know 2/3 works. That's 2, makes it negative 9. 3 times 2 is negative 6. Negative 4. And 4. Yeah, 3, negative, negative. That's not going to work. The 3's cancel, so we have 4, makes it negative 5. Negative 5 over 1 is negative 20 over 3. That makes it negative 18 over 3, negative 38 over 3. So we have 3, makes it -4, -13. So that's let's see what else could I have messed up. For sure, 2/3 works. Four. That's not gonna work. It's -10. Nope, that's not going to work. Let me. Okay, I found the error I made. Is right here. I didn't put this one where I was supposed to. I put it over here. So -1 actually works, which gives me this to work with. So since I know that radical 2/3 works, I can plug it into the one I had here earlier. The one I just found here. I could plug that one in there. 2/3, and it worked again, which then gives us this quadratic equation. Which we can solve using the quadratic formula. A is 1, B is -4 and 2. Plug those in there. Negative is a positive. -4 squared is 16. 4 times 2 times 1 is 8. 16 minus 8. That becomes, remember, it's 8 is 2 times 2 times 2. So that 2 comes out. This 2 stays in. I can factor out a 2. They cancel, so I have that. Which means those are my solutions. -1, 2/3. 2 plus radical 2, 2 minus radical 2. Which satisfies our Descartes rule of signs. We have 1 positive, 1 negative, and 2 non-reals. Set those equal all to 0. These are our factors. All right. Now you're caught up. Rational inequalities. With rational inequalities, we have an added twist to it. Remember, the only x-intercept we have is the numerator. The denominator gives us a vertical asymptote. In other words, we know our x-intercept here is 3x equals 0, which makes it x equals 0. Our vertical asymptote is x plus 6 equals 0 equals -6. So we cannot use -6. So we got to draw the graph. And because our horizontal asymptote is 3, because the degrees of both top and bottom are the same. So our horizontal asymptote is 3. Our vertical asymptote is -6. And the x-intercept is at 0. So since we only have 4 quadrants to look for, it's either going to be here and, well, let's see. It can be here and here, or it can be here and here. They can't be on top because, let's see, if I put -2 in there, I get -6/4. It's a negative answer. If I put +2 in there, 6/8. I put 0 in there, I get 0. I'll put -2 in there. What do I get? -8, -6/4. So the only part we have here for our solution is where? Remember, this is our question. Am I looking for above or below the x-axis? Below. So what part of the graph is below the x-axis? From where to where? Nope, can't be -infinity. Because we have a vertical asymptote. The graph doesn't go past that. To 0, yeah. Because if from -6 to 0. And since it's inequality, that's my answer. So yeah, we have a new twist since we have a rational equation. Example 6. X plus 1 over 2x minus 4 is less than equal to 1. So what do we got to do here? Nope. Did you say set x equals 0? Nope. Because remember, it has to be what on one side? You have to set it equal to 0. So we got to move the 1 to the other side. So we have x plus 1 over 2x minus 4 minus 1 is less than equal to 0. You have to have a 0 on one side. So that's 0. You have to get a common denominator, which is 2x minus 4. So we have to multiply 2x minus 4 top and bottom. X plus 1 minus 2x minus 4 over 2x minus 4 is less than equal to 0. We can drop the first parentheses. There's no coefficient, but this negative changes the signs inside there. So we have minus 2x plus 4 over 2x minus 4. Because you have to have only one equation. You have to simplify it till there's only one equation on the left side in this case. So we have negative 2x plus x is negative x. 4 plus 1 is 5. over 2x minus 4 is less than equal to 0. Now we have only one equation to look at. So what's my x-intercept? What's my y-intercept? My vertical asymptote, horizontal asymptote. So what's my x-intercept? Nope. How'd you get that? Yeah, because we had take the top number, set it equal to 0. So move the x over. So the x-intercept is at 5. The y-intercept is at where? How do you find 5 over -4? So it's -5/4, or -1 1/4. The vertical asymptote, so we got 2x minus 4, set it equal to 0. 2x equals 4. X equals 2. The vertical asymptote is at x equals 2. What's my horizontal asymptote? Now it's -1/2. The vertical asymptote is at 2. Horizontal asymptote is at -1/2. The y-intercept is at -1 1/4. And the x-intercept is at 5. So we see what the graph's going to look like already. Because there are no more x-intercepts, it cannot be up here. It's got an x-intercept, so it can't be here. So it's going to look like this. That's our graph. Example 7. X minus 3 over x plus 4. Are there any questions? If I'm going too fast, please stop me. Same principles here. What's the first thing we got to do? Yeah, so let's move this one over here. So we have,
Why wouldn't you? I think first two over.
you can move this one over there if you want to. It doesn't matter which one, it'll give you the same answer. I'm just moving the entire equation over. So it's minus x plus 2 over x minus 5. is greater than equal to 0. Because I physically took this entire equation and moved it there, so I had to put a minus in front of it. That's the first step. Next step. Very excellent. Yes, excellent. And this one needs an x minus 5. So many students forget to do that next. So we got x minus 5 times x minus 3 minus x plus 2, x plus 4, all over our LCD, which is x minus 5, x plus 4. Because you have to get a common denominator. Very good. What's that? No. I'm glad you said that. If there's a plus or minus in the equation, you cannot cancel that. In order to cancel an equation, it has to be a common factor. It's like saying 3 over 5 divided by 3. 3 over 5 is 8 over 3, right? But if I cancel out a 3, what do I get? Because 3 goes into 3 once. A lot of people miss that. Don't feel bad. So you see, that's why you can't just indiscriminately just cancel. That's why I put parentheses around them. All right, so now we gotta just don't touch the bottom. Leave the bottom the way it is. Now we have to fix the top. The top is x minus 5 times x minus 3 minus x plus 2 times x plus 4. So the only thing we do is the top. So we have x squared, negative 3x, negative 5x, positive 15, minus x squared plus 4x plus 2x plus 8. Combine like terms, we have x squared minus 3 minus 5 makes it minus 8x plus 15. 4x plus 2x is 6x. So I could drop the first parentheses since there's no coefficient in front of there. And inside the second, I have to change everybody's sign because that negative in front. Combine like terms. X squares cancel. Negative 8x minus 6 is negative 14x. Positive 15 minus 8, so it's positive 7. That's as far as we can go. Well, no, we could do, we can factor out. On the top, we can factor out a negative 7, which will give us 2x minus 1. Because they both have a 7 in common. So we take out the negative. Now what do we do? Well, the vertical asymptote, yeah. So our vertical asymptotes are going to be negative 4 and positive 5. So the bottom equals 0. What about a horizontal asymptote? Horizontal asymptote? Nope.
Oh, it's.
Yes. Why would it be 0? There are more x's on the bottom than the top. Very good. Because on the bottom it's x squared, on top it's just x. So it goes to 0. X-intercept. X-intercept. 1/2. So we take this equation, 2x minus 1, set it equal to 0. And x equals 1/2. And the y-intercept? It'd be easier to do the y-intercept from this equation. Only look at the constants. So we have 7 on top, positive 4 times negative 5. It's negative 7 over 20. Which is pretty close to the x-axis. All right, so let's graph that. So our vertical asymptotes are at negative 4. And 5. Horizontal asymptote is the x-axis. The x-intercept is 1/2. And the y-intercept is negative 720. What do we do next? We know that on these corners here, on the outer corners, it's either going to be up here or down here, up here or down there. We know that. But which one is it? Well, let's see. Over here, let's take -5 and put it in this equation. So at -5, we get -14 times -5 plus 7. -5 plus 4. -5 minus 5. All we want to know is the answer positive or negative? If it's positive, we know it's up here. If it's negative, we know it's down here. So that's positive 70 plus 7. That's -1 on the bottom. That's -10 on the bottom. So it's 77 over 10. So we know it's going to be up here since it's positive. Likewise over here at 6. We had -14 times 6 plus 7. 6 plus 4. 6 minus 5. -84 plus 7 over 10. So it's -77 over 10. So that one's negative. It's going to be down here. Now, the problem comes here. What's going to happen here? Is it going to go like this, like I'm expecting? Because we only have one y-intercept and one x-intercept. It doesn't cross the x-axis anymore. So it has to go from there to there. There. It's going to get close to those x-intercept, the vertical asymptotes. Because it has to cross the x-axis there, has to cross the y-axis, and nowhere else. So that's the graph. What do y'all think? All right. That's it for that section.